In this section, we will walk through writing and running your first Spark program in Python, followed by an example of using Spark and SQL in Python. Getting ready. For this section, you'll need to make sure that your Hortonworks data platform, which runs on Linux, is accessible. Either VMware or VirtualBox can host this Linux operating system and the Hortonworks data platform. The first thing you need to do is log into Linux, and to do that you can use PuTTY on Windows, which is what I will do for these videos because it's a lightweight client and gives me direct access to demonstrate the use of Spark in Python and SQL. Another excellent choice is to use Zeppelin notebooks and interpreters from a Windows browser, and you have seen that in previous videos. Finally, there is always the option to use the Linux console, which you can see on the screen here from a VMware guest. Once we're logged into Linux, we're going to load the data files into the Hadoop file system. Then we'll open a Python Spark shell. And finally, we will set up and run a Python Spark use case, a very simple one. And after that, we will load additional data files, open another Spark shell, and run Spark SQL sample use cases. You will find a number of great resources on the internet for using Hadoop and Spark. And a lot of these come from Hortonworks, and other ones come from Apache. So those are the two websites I would recommend to start your search for additional information. The examples that we'll be walking through come from the Hortonworks website, but there's perfectly valid sparkapache.org quick start guides as well. One note is that the warning levels for Spark were reduced from info to warn to reduce the number of messages coming across the screen for these sample exercises. In fact, the log4j properties for Spark are listed here in their default install location, and the log4j properties for each of the systems in this package, this high-performance computing package, can be found by doing a simple search on log4j.properties and changing the levels of warning to whatever you need. So again, supporting information and exercises, there's a good quick start guide from Apache, and there's also a command line tutorial for managing files in the Hadoop file system. So as you start using loading, deleting, and using the Hadoop file system, you'll want to go to that link and look at all the commands available. Briefly, you'll see us use this wget command to go get the Hortonworks Wikipedia page. Next, we will use this Hadoop command to put that file out into the Hadoop file system. And finally, we'll start the Python Spark shell. Okay, so first we will log into our terminal. And next we will run this wget command. And what you will see is that I'm doing a copy-paste of these commands, so they will appear and run very quickly, but I will avoid typos as we go through these sessions. So here you can see all the messages coming across. It went out to the internet, it grabbed that file, and it's saved locally. The next command we're going to run is this Hadoop command that you saw on the PowerPoint slide. So here it comes. Hadoop is now failing, I see, because we have to delete it because it is already there. So I'm going to have to do this manually. Okay, so you get an idea of how fast this will run on a simple laptop. And now I'm going to do a fresh load of that file so it's available. And finally, I'm going to start up the Spark shell. And at the very end here, when it's ready to go, I'd like to point out that it has already set up a Spark context available as SC. And it's also set up a Hive context available as SQL context. So in the default system that they ship to you, it sets these things up for you. Okay, now we're going to go ahead and create an RDD. This is a Spark RDD, and we're going to run two transformations, or more accurately, we're going to set up two transformations because you'll note that nothing happens. That's just due to this lazy eval. But it is setting up a DAG or a processing graph to execute when we do run into an action. Okay, first thing is to paste in this command. So now my data is the RDD that was created from the text file stored in the Hadoop file system at this location, temp Hortonworks. From here, we're going to set up a transformation. So now we're going to have some lines that are filtered. They're basically all the lines that are greater than, that have a character in them. They're not length 0. And then we're going to set up another transformation. 4 lines with the word Horton in them. Now that we have those transformations queued up, we'll make something happen here. First of all, the first action will be to count the number of filtered lines, and the second action is to display the first line with the word Horton in it. So here we go. We executed this command, and the answer is 311 lines. Again, these warning messages come through from various facilities, but the answer is correct. It's here, 311 lines. The next action is to display the very first line in the Wikipedia entry with the word Horton in it, and there it is. Once your system is working, or even a part of planning, should be thinking about how to chain your transformations together. In this very simple example with the My Data from the previous slides, you can chain together the transformation, which is seeking out the lines with Horton in them, and the action, which is counting, giving Spark the opportunity to consider optimizations of this transformation and action together. Of course, what your goal will be is putting together far more complex transformations before actions are actually executed, and giving Spark the opportunity to optimize the runtimes. Spark is powerful because it can run your workloads across multiple worker nodes. So there's a driver node, and it splits out the RDDs across worker nodes, and then it runs the actions on all the worker nodes. In this simple example here, it's just showing one driver with 3 workers, but you can picture tens or even hundreds of workers running across very large data sets. There's also the topic of caching some of your data out on the workers. And in the next slide, I'll show you how to do that. So when you have a large data set in a cluster-wide system and you want the in-memory cache for very fast, in fact blazing fast access, you'll want to use the cache command here. So in this simple example, for example, the Lines with Horton dataset would be cached in memory, and all the actions that you run across them then will run very quickly. MapReduce is very popular today to run workloads on Hadoop clusters, and Spark implements MapReduce flows simply, that is, in a straightforward manner. The following is an example of taking a text file and doing a map and reduce in the same fashion as Hadoop would execute it. As we have only touched on the use and power of RDDs, I would recommend that you go to the programming guide for Spark at spark.apache.org. Shifting gears now, let's walk through your first Spark SQL job. To support the distributed computing power of Spark, data frames have been introduced as a form of distributed data organized into named columns. They're conceptually equivalent to a table in a relational database, and you'll see that we can query them with SQL syntax. But there's richer optimizations under the hood for data frames. Additionally, as background for you, data frames can be constructed from an array of sources. For example, just structured data files, tables in SQL, external database, or existing RDDs. In our case, we'll be using existing RDDs. One interesting aspect of converting an RDD to a data frame is that SQL can infer the data types as it converts an RDD row of objects to a data frame. The keys in the list will define the column names of the table, and types are inferred by looking at the attributes of the first row. So let's get started. The example we'll walk through here is from the SQL programming guide, again at spark.apache.org. So here we are back at our Linux command prompt, and the first thing we want to do is to grab a text file and put it out into the Hadoop file system. Again, you'll see the command appear quickly because I'm just going to paste it, and right now Hadoop is busy reading in this 2-line file into its data system, and now it's ready for use. So the entry point into all relational functionality is the SQL context class, or one of its descendants. Note that you can create a Hive context as well, because that's a superset of the functionality. So let's get started here. We'll start up the PySpark shell. And the first thing we'll do now is import the SQL context. Then we will get access to a SQL context. So the first thing we will do is convert each line from the text file into an RDD row. Then the cool thing here is that we'll be able to infer the schema as we create a data frame as a table. So step one is go to the Hadoop file system and get that people.txt file. It only has a couple of names in it because that's all we need for our example purposes here. Now we have the lines and we want to create RDD rows from them. So here we go. Now we have the row parts because we split each row based on the commas. And finally, we're going to end up with the people RDD. and that RDD has a row which is a name and an age in each row. So from here, we're going to actually create a SQL data frame. A little bit more work, a few warnings, but it was successful. So looking at this, we went back to the SQL context that we created up above. We used the create data frame against the RDD of people and put that into schema people. Now we need to quickly register this, and then it will be ready for use. So now we can run SQL commands over the data frames that have been registered as tables. And the result of the SQL queries are RDDs, and those support all the normal RDD operations. So we'll continue our example here by pasting in a SQL query. That is, we selected the name from the table people where the age is greater than 19. So these are not teenagers. And to demonstrate that we really have those, we will piece together the text name along with a name from each row in the table. And then finally, we will print this out so you can see. In this case, I believe we end up with only one name, but you can easily see how the system works and the power it can bring to you as a data scientist. I'm sorry, there's two names, Andy and Michael. So there you have it, running SQL queries against a data frame and the power it can bring. In summary, I believe we have demonstrated how Spark, Python, and SQL together are powerful partners in productivity for the data scientist. Spark RDDs providing the underpinnings along with data frames, but provide the underpinnings for powerful tools for scalability and speed.